Here we have a problem and we are asked to calculate the currents flowing in these branches. So it means I have to calculate I1, I2, I5, I4, I3. Okay, here I think we can use the mesh analysis to calculate the current, but here we will have three equations with three unknowns if we take the mesh currents. But here we are going to use a different step. Here we have to transform. We can transform this delta or this one to star. Same thing here. We can. This is a star. We can transform it to a delta. We will try to transform this to a star, and we will see the results. I'm not going to. I have made some films about these transformations. I will give you the results of the calculations. If we call this one R5 prime and this one R3 prime, and here we have R1 prime, we can transform it. So R1 prime is R3 times R5 divided by R1 plus R3 plus R5. R3 prime is equal to R1 times R5 times the sum of the three. Okay, R5 prime is equal to R1 R3 over R1 plus R3 plus R5. Here we have R3 times R5, so it means 4 times 16 over the sum of the 3, which is 2040. Here we have 40, R1 is equal to 20, R5 is equal to 4, and here we have R1 20, R3 times 16 over 40. So R1 prime, where is the calculator? 4 times 16 over 40, this is 1.6 ohms. 20 times 4, this is 2 ohms. 20 times 16 divided by 40, it's 8 ohms. So here we can redraw the circuit and we will see how it looks. Here we have R5 prime and we have two circuits here, R3 prime with R2. Here we have R1 prime with R4, R2. Here we have I2. Here we have I4. So we can already calculate the equivalent resistance, and we can calculate the main current here. So the equivalent here, of course, let's put the values. 1.6 ohms, here it's 4.4 ohms, R3 prime is 2 ohms, and here 10 ohms, and R5 prime is 8 ohms. So we can calculate now our the equivalent resistance of this circuit. The equivalent resistance of this circuit, we can write it here. Our equivalent is R, small letter, plus R5 prime, plus the two resistors which are in parallel, R3 prime plus R2 times R1 prime plus R4 over the sum of the four resistors. So it means we have here it's 2 ohms, we have 2 plus 8 plus 12 times 6 over 18. So it's 2 plus 8 plus 4, so it's 14 ohms. So from here we can calculate the main current. Which is I is the main current. I is equal to E over the equivalent resistance, and it's 28 over 14, and it's 2 amps. From here we can calculate I2 using the current divider. I2 will be equal to R1 prime plus R4 over the sum of the four resistors, R1 prime plus R3 prime plus R2 plus I4 times the main current. And here it's R1 plus, this is 6 over 18 times 2. This is 6 times 3, 2/3. 2 divided by 3, it's 0.67 amps. So it means that I2, if I2 is 0.767 amp, I4 will be the difference. I minus I2 is 2 minus 0.67, and it's plus 2. This is 1.33 amps. We have calculated the currents I2, I4, and the main current. We to calculate the current flowing here, we have to know the voltage drop here. Remember that the current that flows here will flow here and here, and here we have a drop like this and a drop like this. The highest potential, if the current flows like this, the arrow shows the highest potential. If we call it VO, so it means that VBD plus VOB is equal to VOD. So VBD will be equal to VOD minus VOB. So it means that VBD is equal to VOD. VOD, it's R1 primes times I4 plus minus VOB. VOB, it's R3 prime times I2. So it means that we have 1.6 times I4, 1.33 minus 2 times I2, 0.67. So it means that times 1.6, this is 2.13 minus 0.67 times 2, this is 134. So it means VBD it's about 0.8 volts. And from here we can calculate I5. I5 will be equal to VBD over R5, and it's 0.8 over 4, it's 0.2 amps. We have calculated I5, I2, and we are left now to calculate I1 in this node. We have I1 is equal to I1 is equal to I5 plus I2. It means that I1 is equal to 0.2 plus I2 0.67, so it means I1 is 0.87 amps. And we're left now to calculate I3 plus I5 in this node D is equal to I4. I3 is equal to I4 minus I5. I4 is 133 minus I5 0.2. It means that I3 is equal to 1.13. Excuse me, I used a comma. Should be point everywhere. Okay, I forgot that English use point instead of comma. I change it a little bit. Okay, this is what I had to say about this problem. We can of course use a mesh current here. We have two meshes, and we can calculate I2 and I4 as well. So I used the equivalent resistance to calculate the currents, but we can use the mesh current here and the mesh current here as well. We will have two meshes, whereas here we have three meshes. And thank you very much for your attention.